So good morning, students. Today, our chemistry class is going to be in another form. Today is just my birthday. I just want to take things at random. Now, let me just tell you guys electrolysis. Remember that electrolysis is the chemical decomposition of a substance with the aid of electric current. That carries us to Michael Faraday, first law of electrolysis, 1833. The father of electricity, which states that the mass M of a substance is directly proportional to the quantity of electricity flowing through it. So you introduce your constant of proportionality like you have a mass, you have M is equals to ZQ, or you have something like M is equals to ZIT. Your M is the mass, your Z is electrochemical equivalent constant, which is in gram per coulomb. Your I is current in amperes, your T is time in seconds. Under electrolysis, most times you can use a formula on the calculations. You have M over MM is equals to Q over NF from the second law. I get now. Your M is the mass, your MM is the molar mass. For example, they give you something like copper. Maybe you're looking for the quantity of electricity or whatever they also to look for. Basically, if you can get acquainted to this formula, I'll get it now. M over MM is equals to Q over NF. So that is the formula. Q is quantity of electricity, or you can use IT. If they give you your Q in coulombs, you are good to go. I get now. If they don't give you your Q, they'll give either your amperes or your time. And always make sure that you convert it to seconds. If it is 60 minutes that they gave you as the time, first of all multiply it with another 60 to convert it to seconds. Something like this, also 6 times 6, 36. Pack your two zeros together. If you have something like 500 times 300, let's do 5 times 3, 15. Pack your 0, 1, 2, 3, 4. 1, 2, 3, 4. Then your N is number of farad. This N is number of valence electron, while your F is the Faraday. If it is still safe, if it is also copper is divalent. So that's why we need to go back to the SS2 concept of redox form. Copper can be written as Cu2 plus 2E minus to give you my Cu solid. Copper cupron. I don't know if I've told you guys before that anything that is carrying charge is always aqueous. If you see something like hydrogen ion and the right solid is wrong, something is wrong somewhere. Again, anything that is carrying charge, either positive or negative, will always be in the aqueous state. You can study the concept of electrolyte. So if it is copper that we're talking of in a question like this, so your NF is now going to be 2F. 1F is a constant, 96,500 coulombs. So if it is 2, that will be 192,000. If it is something like aluminum is trivalent, Al3 plus 3E minus to give my Al solid. So if it is aluminum, that will be 3F. You multiply your F by 3. So that's basically under that. Now, under this electrolysis transfer, if it is evolving gas, you have something like Vg over Vn is equals to Q over NF. If it is evolving gas, this is the volume of the gas. This Vm is molar volume of gas at test P, which is 22.4 dm cube. Then your Q and NF is what I've explained initially before. So that is for that. Basically, I'm just trying to take a random aspect of chemistry, physical, organic, and the like. And then just quickly go to the concept of organic chemistry again. Some of these things are in my previous video. I'm just trying to make it like a birthday gift to my students. This OGC is what I call organic chemistry. People used to dread it. To dread something means to be scared. You know, you are kind of scared of organic chemistry, but it's very easy. I first of all try to make it easy from the concept of hydrocarbons. Hydrocarbons are compounds that comprises majorly of hydrogen and carbon. Hydrocarbons are broken down into two. You have your aliphatic, you have your aromatic hydrocarbon. Under this one, you have benzene as a very good example. Or most of your cyclic compound. Benzene is C6, H6. August Kekulé was the name of the scientist that discovered a ring-like structure for benzene. I get now benzene has a ring-like structure. Now for your aliphatic hydrocarbons, we have two. We have the saturated, and unsaturated. Saturated and unsaturated. Under the saturated hydrocarbon, we have alkene, alone. I get now alkene. Then under unsaturated, we have alkenes, ene, and alkyne. All together on this now, I want you guys to follow to some of this aspect of chemistry. There is a goal I work with students, C.M.E. Chemistry Made Easy. That is one of my goals. I get now to make chemistry easy. How to get now? So please, I need you to help me to make chemistry easy from your feedback and questions and etc. Alkenes are also called paraffins. They're also called paraffins. Alkenes, sometimes we refer to them as olefins. Sorry that the light is being blurred. Alkynes are also referred to as acetylene. Acetylene. I get now this one, they are sp3 iodized alkene, sp2 alkyne, sp. Let me switch back so I can see what I'm writing. I get now. The S and P is what we refer to as sigma to pi bond. I will explain that under hybridization. So the next one now is the GMO, general molecular formula. Here you have CnH2n plus 2. For the alkene, we have just CnH2n. Then for the alkyne, we have CnH2n minus 2. Then we have another one that we refer to as alkyl. I love to discuss on this separately. This one is CnH2n plus 1. Though this one is when you move one hydrogen atom from alkene, it gives you an alkyl. Like there was one I was treating with student yesterday about under functional group, we have NH2 amino. Then when you remove an hydrogen atom from NH2 amino, you are left with what we call alkyl. That one is alkyl amide as a functional group. So coming back to this one I'm explaining now, if methane is CH4, the simplest hydrocarbon that we have, CH4 methane. If you remove an hydrogen atom, that would be CH3. So that would be what? Methyl. Altogether now, methyl. So if you want to do for methyl now, you now C1 H2 open bracket 1 plus 2. That will be C1. I'm just trying to go. So a plus 1 rather is plus 1, that is a plus 1, that will be 2 plus 1. That will give you CH3. Again, and just how you derive this. This is the simplest alkane. Why the most complex alkane is what we call L-cozen. That one is C20. I guess now L-cozen. Now let's continue now. You see, I give student a scope. So met is 1, et is 2, prop is 3, boot is 4, pent is 5, eggs is 6, hept is 7, oct is 8, nona 9, then deca. Then we have undeca, dodeca, and the likes. But for now, let's focus on this. So alkane, single bond, alkene, double bond, alkyne, triple bond. So when you see something like, you can derive formulas, any compound with this basic scope. If it is, for example, under your alkane that has 4 carbon atom, that is just what? Butane. 4 carbon atom. Butane. 4 is but. They will change suffix if it is alkene. Now let me just quickly discuss on 2 functional groups basically. We have what we call COOH. Whenever I see COOH, acid comes to your mind, alkanoic acid. They have the carboxylic acid as the functional group of the alkanoic group. I get now. Carboxylic acid, COOH. Carboxylic acid is made up of carbonyl and hydroxyl. They also have another one called CO, carboxylate. These ones are for esters. Esters have sweet smelling savour. There's an ester found in pineapple that gives pineapple the sweet smelling savour, and there's also an ester found in banana. Again, now there's a question I was in biology one time that esters aid pollination. Is actually true because the scent will actually attract the agent of pollinator to pollinate the flower. Remember that pollination is the transfer of pollen from the anther of the flower to the stigma of that same flower. That's self-pollination. Then if it is around stigma of another flower, that one is cross-pollination. Now let me go to another concept again. I just want us to digest this. I'm making like 3 videos today. From the board, I used to tell students that they have something that we call nonsense. Nonsense. At the back of nonsense, you can bring out sense. I will get to know. There are a lot of sense you can bring out. Again, from electrolysis. Then, like even from your gas laws, you hear something like Boyle's law, the volume of a fixed mass of gas is inversely proportional to what? It's inversely proportional to pressure. So for every real law, try and know the mathematical representation. Anytime you have something like this, there's a mathematics. The next thing is you're expected to introduce your constant of proportionality. So you have V is equals to K over P cross multiply, that will be VP is equals to K. By comparison of two similar gases, that will be V1 P1 is equals to V2 P2. You have the second one as well. Charles law, the volume of a fixed mass of gas is directly proportional to temperature, absolute temperature in Kelvin, provided that pressure remains constant. So here introduce your constant to as well. Once it is direct, that is just like face my face you. So that will be V is equals to KT divided by T. So you have V1 over T1 is equals to V2 over T2. So that's basically for that aspect. So if I see something like this, I can actually, from this expression, that's why science student has to be mathematically inclined. From this expression, I can see one or two things about Boyle's law. The volume of a fixed mass of gas, or the volume of a gas, is this is inverse. Inverse is just like 1 over 3. Inverse of 3 is 1 over 3. You can write it as 3 inverse 1. I guess now, inverse of 3. So this is just like the volume of a fixed mass of gas is inversely proportional to pressure. That means temperature, which are the other factors required, temperature and pressure. That means if inversely proportional to pressure, that means temperature was actually what? Constant. Was actually constant. Now let me quickly go to Graham's law. I've done Graham's law several times. Still relating to what I'm saying. Graham's law of diffusion is applicable to gases alone. Let me come down so every one of us can follow. You have the volume. Graham's law states that the rate of diffusion the rate of diffusion of a gas, the rate of diffusion of a gas is inversely proportional to the square root of the gas density. This is the expression. So the next thing is what? Introduce your constant of proportionality. That will be R is equal to what? K over root D. By comparison of two similar gases, you are going to have what? R1 over R2. So here is going to be what? Square root of D2 over D1. This is equation 1. I know I've made a video on this before. There is a relationship between vapor density and relative molecular mass. Let me clean one side of the board so that the board will not be too rough. Remember that 2 times Vd will give you RMM. 2 times Vd, this is D. So you can this has to be D and M. So there's a relationship between vapor density and molar mass. So I can now equate this place that I have the D density. I can replace it with my M because of the relationship connecting them. So I can write another formula that says R1 over R2 is equals to square root of M2 over L1. Yeah, I decided to write the square. I factorize the square root. You write square root like this, M2 over M1, or you write it as M2 over M1. You are still on point. All together now. Now, rate is the reciprocal of time. Rate is the reciprocal of time. So this one will be my T1. So here is going to be my T2. So another formula says T2 over T1 is equals to square root of M2 over M1. You can see that I've written close to like 3 formulas under this. Though the most popular one, or the last one, which is rate of diffusion, is equals to volume diffused over time taken. That is why that one is centimeter cube, this one is seconds. So in that situation, you have the SI, the parameters to be centimeter cube per seconds. Now let me quickly go to another concept. Like I said, today is I'm just trying to discuss briefly. Let me just tell you about acid and base. We all remember the definition for acid. An acid is a substance that produces hydrogen ion as the only positive ion when dissolved in water. Bases of an acid, the number of replaceable hydrogen ion. For example, you have something like HCl. HCl is monobasic. It has only one replaceable hydrogen ion. If you have to write let me quickly dissociate. Let me also teach you guys. If you want to write this is HCl, most times acid are aqueous. An aqueous substance is a substance that will dissolve in is what? In a solution. So as far as acid can dissolve in water, acid is always aqueous. So here you're going to have H plus AQ plus Cl minus also AQ. This state of matter is very, very optional. It's not compulsory. Then let me quickly teach you guys something about K, equilibrium. Equilibrium symbolizes K. The way you get higher, will teach you KC, KP, KQ, K water, KSP, solubility products, etc. etc. KW, that one is for ion dissociation of water. So yeah, if you want to write your K, it's going to be product over reactant, the concentration. So that will be K is equals to, for the product here, will be H plus dot plus turn to minus Cm minus over what you have in the reactant. That will be HCl. This is how you write equilibrium expression. And you can only get equilibrium for reversible reaction. Take note of that. Basically, you can only get equilibrium for reversible reaction altogether now. So let's take note. Then there's something that you need to understand that if we add 2 here, this is 2 moles of HCl, the molecularity becomes the order. So this 2 comes here to become a power. So that will be 2 in case you have something like that. Now for water, ionic dissociation of water. I didn't actually render this video to pass 10 minutes. Ionic dissociation of water, we just used to use KW. It's kind of neutral. Now you have water to be H2O. By the time you split it, that will be 2H plus OH minus. Okay, yes. H plus OH minus is balanced now. Water is liquid. This one is aqueous. I've told you guys anything kind of charge is aqueous. So that will be K is equals to H plus dot. I use dot 4 times, but you can, it's not necessary to put it there. H minus over, that will be what? H2. So this is ionic dissociation of water cross multiply. This one really does to another aspect I would love to teach. So you're going to have something like KH2O. KH2O is equals to H plus dot OH minus. This is a neutral substance. You can see here, you can see acid. Acid is the substance that produces hydrogen ion. A base is the substance that will produce hydrogen ion. When you have acid and base, it gives you a neutralized form. Remember neutralization reaction? Neutralization reaction is a reaction between an acid and a base to give salt and water. So it is being neutralized. So that's why we say that K is equals to, this is what led to the concept of 1.01 times 10 to the power minus 14. When you get to pH, that concept of pH plus POH is equals to 14. Potential of hydrogen. Now that is why it leads us to another aspect entirely. I think I've once made a video of this before too, one time like that. So just that for a neutralized solution, that it will go back to PSK 0 to 7, 7 to 14. Though basically 0 to 4 is one that's acidic, 7 is neutral, then the lysis. So hydrogen ion is, that will be 10 to the power minus 7. Then hydrogen times 10 to the power minus 7. Again, so mathematically expressing it, that will give us what? In logarithm, when you have times you plus minus 7 plus and minus is minus, so you still have 10 to the power minus 14. So that's where we get that. That's where that constant was gotten. And that 10 to the power minus 14, they introduce log, negative logarithm of all sides. So by the time you introduce negative logarithm of 10 raised to the power minus 14, negative logarithm of 10 raised to the power minus 14. Under, I gave student the telos of log. There's also called logarithm of its own base. Log 10 base 10 cancel, you're left with minus 14. Minus 14 cancel, you're left with just what? 14. So that's where you have your what? 14. I would have loved to explain that aspect, but I spent close to like 15 minutes on this. So I want us to actually comprehend and understand this aspect of chemistry very well. Feel free to ask me questions. I'm actually in the mood to answer any of your questions related to chemistry. Remember that there is a goal. Chemistry made easy. I'll get it now. Focus on organic chemistry. No matter a compound is, whenever you see a compound, maybe you just draw a compound like this, and you see something like just that. As far as you are saying single bond, just know that compound is an what? Is an alkene. I stop here for today. Good morning. Have a nice day.